Good. So how to picture it in your head without a graphing calculator. And then as we, I think in a Wednesday's lesson, what happens when you start adding different, you're not variables in terms of X and Y, but when you're adding change to a parent function or a common function. Good. Piecewise is totally different. Piecewise is what if you take two different graphs and put them together? Okay, so we will go over the constant function, the linear function, which we've all worked with a lot already in this class, the square function, which is just x. Let's talk about what they are. The constant function is just y equals a number. Good. Remember that y is f of x, so f of x equals a number is the constant function because it can't change depending on x, right? Then we have y equals x or f of x equals x, so that's just going to be one line, right? Then we have the square function where x is squared. What happens to the graph then? What happens if we cube x? What happens if we take the square root of x? Good. What happens if we put x within the absolute value bars? And what happens if we put x in the denominator of a fraction? Good. So that's what we're talking about. Then we will go on to two examples of piecewise functions. And that's what we're doing. I wanted to say piecewise is not as important, but we'll just say it's all important, right? Make sure you have a picture in your head when somebody says f of x equals x. That's not page 1. Make sure you have a picture in your head when someone says y equals any number, okay? Let me get started. The constant function is just f of x equals c when c is a constant or any number. It's called the constant function. C is constant. C is any number. We call it constant because if you make y equal a number and there's no x value, your graph is not going to change according to what x you put in. It's constantly at the same y value, no matter where the x is, okay? No matter which x you choose, your y is always 3, for example. Good. Let c equal 3. Create a table of values using -2, -1, 0, 1, and 2 for x, then graph the function f of x is 3, okay? Let's think about it. When x is, they said -2, -1, 0, 1, and 2. Again, when you're making a table of values, we just start at 0 and the terms closest to 0 because that's easiest. Generally easiest, and it gives you an idea of what happens below the x-axis and above the x-axis. So you get negatives and positives, but you try to keep the numbers small because you're kind of doing it by hand, right? So if x is -2, f of x equals 3 means we put in -2 for x. If we put in -2 for x, nothing happens to 3, right? Because there's not even an x to replace with -2, right? It's just x is -2, y is +3. If I say x is -1, what does that change 3 to? 3 remains 3. So that's why it's called the constant. No matter what x value, there's no x to replace, input into the equation. So your y remains the same. -2, 3, 1, 3, 0, 3. +1, 3. Two, 3. So a constant function, f of x equals a number, is a horizontal line. -2, 3 means I go out to -2, up to +3, -1, also at +3, 0 is at +3, 1's at +3, 2 is at +3. Good. You are also welcome to just put f of x equals 3 into Desmos and look at it. So constant function where f of x equals the constant is always a horizontal line. So f of x equals c is a horizontal line. If it makes more sense to you to just pick a number for that, you can pick a number for that. Whatever that number is going to be your y-intercept, right? Because my y-intercept is at 0, 3. That's the constant function. This one is called the identity function, but it's easier or more commonly called, it's easier to understand and more commonly called the linear function because y equals x makes a straight line that crosses y and crosses x. So linear because it's a line, or identity because it includes both x and y. An exponent, what is the exponent here? It's understood one, right? So an exponent of understood one always makes the function linear. You don't see the number 1, but you know if there's no number there, it's just x to the first power. If you have a y and you have an x raised to the first power, your function is a line. If you have a y and you have an x, it's going to cross your y-axis and it's going to cross your x-axis. Good. So for this linear function, create a table using -2, -1, 0, 1, and 2. Replace each of those for x and graph the function f of x equals x. So when f of x becomes f of -2, x becomes, or the whole f of x becomes -2. So my x was -2, and the answer, which is y, the outcome is -2. Everybody okay with where I'm getting my y value? My y value is f of x, right? F of x is y. So this y means what is the answer? Good. So my x is whatever I put in. I can even do that before I even do any math. I can just say, if this is -1, this is going to be -1. If this is 0, that's going to be 0. If that's 1, this is going to be 1. If that's 2, my first term is going to be 2. Good. And then when I replace x with that number, what is my y? What is my outcome? If my whole equation is just x, my outcome is just going to be x. So f of 0 is 0. F of 1 is 1. F of 2 is 2. So those are my points. The point -2, -2 means -2 on x, -2 on y, -1, -1, 0, 0, 1, 1, 2, 2. Good. So that linear function is a line, but a line that is going through both your y-axis and your x-axis. F of x equals x looks like this. All right, so that's the takeaway. F of x equals x looks like this. F of x equals c looks like this. The cube, nope. Constant, identity. Oh, I turned off all my pages in my preview. Square function. So the square function means that you squared x, right? So this is an exponent of 2. So it cannot be a straight line. Just put y equals x squared into Desmos. See what it gives you. Good. Create a table of values using -2, -1, 0, 1, and 2 for x, then graph the function f of x equals x squared. F of -2 equals -2 squared. Should respect the parentheses. So when x is -2, y is -2 squared. -2 times -2 is a +4. So it's actually -2, +4. -1. -1 times a -1 is a +1. 0 means I'm going to square 0 and I get the origin, 0, 0. Now I'm going to go to +1. 1 squared is just 1. So if you notice, I'm mirroring the numbers because -2 squared is going to give me the same answer as +2 squared. They're both going to be 4. So when my x is -2, my y is 4, and when my x is +2, my y is also 4. This is an example of a function where the y's repeat, and that's okay because the x's are not repeating. So the takeaway right here is the graph of x squared looks like this. So we're just talking about the parent functions, okay? The graph of x looks like this. The graph of a constant number looks like this. This is called a parabola. After the square function, we're going on to the cube function, okay? Same thing. So x is being raised to a third power. Whatever you input as your x, here it's the same terms, -2, -1, 0, 1, and 2. Whatever I input is going to be raised to the third power, multiply times itself thrice. Multiply itself 3 times, multiply it by itself 3 times. F of -2 is -2 to the third, right? -2 times -2 times -2. So what happens if it was just -2 times -2? If it was just squared, it would be a +4, as we saw on the last problem. But if it's a negative times itself 3 times, -2 times a -2 becomes a +4. 4 times -2 is a -8. So the cube function, if you put in a negative, you get out a negative because a negative times a negative is a positive, but that positive times the negative is another negative. So that is -2, -8. Good? Just some general rules to keep in mind. -1, so -1 cubed. -1 times a -1 is a +1. +1 times a -1 is a -1. So -1, -1. 0. 0 raised to the third power is just 0. 1 cubed is 1. I write too big for these boxes. 2. So I'm taking 2 and I'm cubing it. 2 times 2 times 2 is +8. So they're almost mirroring each other, but keeping the sign of the original x. So this term is going to be -2 on the x, -8 on the y. So it's right here. -1, -1, 0, 0, 1, 1, 2, 8. So your graph of a cubed function Did a terrible job. It looks a bit like this. So f of x is x cubed. Looks like that. X squared looks like that. X looks like that. C looks like that. We're just memorizing these. That's called constant. That's called linear. That's called square. That's called cube. After our cube, we have the square root, okay? We're going to create a table of values, but we're not going to use -2 or -1. Why? Yes. I will check my email after this class. No problem. So we're not using negatives because if you remember, when we put a negative under a radical, we get an imaginary number, right? Then that becomes I square root of 2, right? And you can't put I square root of 2 on a graph on a plane that just has X and just has Y. So you can't graph the square root function below 0. The square root function, the graph of the square root function starts at 0. And we're not going to use 2 because the square root of 2, if I put that into my calculator, wow. All right. If I put the square root of 2 into my calculator, I get a decimal. However, if I were to put the square root of 4 into my calculator, I get a nice whole number. So I'm going to use values that are perfect squares so that I get a nice point to graph. I don't get a decimal to graph. So I'm going to do 0 because the square root of 0 is 0. I'm going to do 1 because the square root of 1 is 1. I'm not going to do 2, I'm going to do 4 because the square root of 4 is 2. So that point's going to be 4, 2. And then I'm going to do, what's 3? 9. F of 9 means the square root of 9 is 3, right? And this isn't cheating, it's just good planning, right? And then 4 is 16. So if I put 16 in for x, I get the square root of 16, which is 4. So 16 and 4. I'm going to graph those, or a couple of those. It goes through 0, 0. It goes through 1, 1, 4, 2, 9, 3. So you can see that the curve is flattening, but it's curving in a positive direction, and there is nothing below. Sorry. There's nothing below 0, below the x-axis, below x equals 0, because that's an error, not a real number. There's no arrow here, but I did draw an arrow there because it can go on forever in a positive direction. These are all perfect squares, didn't want to graph decimals, so I chose only perfect squares. So that's the square root function. F of x equals the square root of x. Looks like this. Absolute value function, just think about what absolute value means, right? Absolute value, anything inside the absolute value bars, it's just asking what is this value's distance from 0 on the number line. And 0 is always positive, right? So the absolute value function is will always output a positive number. It's not like the square root function, because the square root function, you can't even put a negative into for x, right? Absolute value, you can put in a negative x, you can put in a -2, and you get out a +2. All right, the absolute value of -2 is 2. The absolute value of -1 is +1. The absolute value of 0 is 0, because 0 is 0 distance from 0. +1 is 1 unit away from 0. Good. So we're not saying that because your y is always positive that you can't have negative x's. You can have negative x's, you won't have negative y's. So it looks like, if we think about what is f of x equals x, looks like this, right? And where are my, here's my graph. And where are my negative y's? Yes, anything that's inside this must be positive. Good question. All right, so here it is on my graphing calculator. You could put 3 minus 500 times 2. That should be a negative number, right? Because you're subtracting a very big number from 3, but because it's inside, you do all of that work inside, and then when it comes out, it is a positive number. That is just how far is that from 0? Distance is always a positive number. So if this is f of x, good question, thank you. F of x equals x, think about where it is negative, right? So here's my line for positive y values and negative y values, right? So all of this does not exist for the absolute value function. It looks the same, right? It's still f of x equals x. But when we put absolute value bars around it, those numbers stay the same, but they start growing again in a positive direction instead of becoming larger negative numbers as they do for f of x. They just switch. They keep getting bigger, right? -3 will be a +3, -4 will be a +4. So they're going to keep increasing, but they're not going to go in the negative direction. They're going to go back in the positive direction. So the absolute value function looks like f of x, but we took that piece of f of x equals x, and we moved it so that it's always positive. So -2, 2 is going to be here. -1, 1 is here. 0, 0, 1, 1, 2, 2. We took that graph, shifted it. So you have a piece, when we talk about piecewise functions in a minute, you have a piece of f of x equals x, but over here it's doing something else because the absolute value will never go below the x-axis. So the square root function and the absolute value function do not go below the x-axis. Finally, we have reciprocal function. Remember, reciprocal means flip. Good. The graph doesn't flip. The graph looks very different. for this one, the reciprocal function, instead of just f of x equals x, is a parent function, right? And that you can think of as x over 1, because anything divided by 1 is itself. So we're going to flip that, and we get f of x equals 1 over x. So we flipped it from the top of the fraction for the numerator into the denominator. We just flipped it. Reciprocal means flip. Again, we'll use the same terms. So they gave us more. -3, -2, -1, 0, 1, 2, 3. Good? Okay. So when x is -3, that means I'm dividing 1 by -3, right? 1 divided by -3 is just -1/3, which is the fraction 0.33333, right? So when x is -3, y is -1/3. When x is -2, y is -1/2, right? When it's -1, 1 divided by -1 is still a -1. So that one's okay. What about 0? What if you try to divide 1 by 0? You get undefined. You cannot divide by 0, so it does not exist. There is nowhere that it does not exist on the graph. The graph does not exist at x equals 0. Good. Over to positives. When it's a positive 1, it's still 1 divided by 1, which is 1. So 1, 1. It will cross at 2, 1/2, and then it'll cross at 3, 1/3. So it's kind of like the kind of like f of x in that, or it's kind of like x squared, and that you're mirroring it. No, I won't say that. Never mind. All right, but it is important that you know what this shape is. This is the oddest of the shapes, the least known of the shapes. So our highest value is 3. So when x is a -3, y is a -1/3. When x is -2, y is a -1/2. When x is -1, y is -1. So you see how it's getting smaller as it goes out? It doesn't exist at 0. When it's at +1 x, it's at +1 y. When it's at +2, it's at +1/2. Oh, sorry. And when it's at +3, it's at +1/3. So what you see if you graph this function, I did not graph it very well because those weren't very good terms, is it's going to approach 0, and it's never going to touch 0. 0 is an asymptote. So the reciprocal function f of x equals 1 over x looks like this. This is called, sorry. Where it is undefined, that is called an asymptote. So that is a vertical asymptote. Those two sides of the graphed equation are going to approach and never touch the vertical asymptote. At x equals 0. Where x equals 0, the graph will never All right, so we've got them all. We've got the reciprocal function. We've got, and make sure you label it. That's the reciprocal. We've got the absolute. And note that the absolute value is always above the x-axis. Then you've got the square root. F of x equals the square root of x. That one's going to go like that. Then you've got the cube. F of x is x cubed. It's going to look like that. Square means x is squared. It's going to be a parabola. The linear one, x is raised to only the first power, so it's a straight line. And finally, we have constant. Just y equals a number. Note that it does not cross the x-axis. It does not cross the x-axis. The rest of them can move around and cross the x-axis, but this one will not. Good. All right, so the rest is called piecewise defined functions. So intervals on a graph, a function can be a combination of two different functions. A function can be a combination of two different functions depending on defined by the intervals that it gives you. So for example, this graph says that if before x equals 1 so picture the graph x and y, picture x equals 1, okay? It's like it's a vertical line at x equals 1, okay? Before x equals 1, so when x is less than 1, you're going to have the graph 2/3 x plus 1. Good. After that x equals 1, when it is at or above, so to the right of x equals 1, the graph is going to become the graph of -2x plus 1. Okay, so they're asking us to graph that. So you can graph it on Desmos. We can come back and graph it later if we have time, but I don't think we will. All right, so we graphed it on Desmos. We saw that the change point is when x is equal to 1, right? Before x is equal to 1, we're going to use this. After x is equal to 1, we're going to use this. So graph it on Desmos, find f of 0. F of 0, should I use, color them, should I use the pink one or the blue one to find f of 0? Sorry, that's probably very loud. Think about what's happening. Good. So until, here's 1. Right? X is 1. Up until 1, I'm going to use this one. 2/3 x plus 1. So if I had to graph that, let's just graph it. I'm going to start at my y equals mx plus b, right? My b is 1, so that means I'm going to cross my y-intercept at 0, 1. And I'm going to go up 2 over 3, right? Up 2 over 3, but it doesn't exist past this line, so I'll just go down 2 over 3. So here's my line. For that first one. 2/3 x plus 1 is that. It does not exist at x equals 1, right? So you actually have to call this a hollowed out line or a hollowed out point because it doesn't exist there, right? If it's equal to 1, we're going to go to the negative 2x plus 1. Good. So negative 2x plus 1 means my intercept is also at 1, but my slope is negative 2, 1, right? And up here, sorry, my slope is positive 2/3. Good. So from that same point, to graph this other one, I start at the same y, and then I go down 2 over 1, down 2 over 1, and I'm going to graph that line. But I'm only going to graph it to x equals 1. This line is, or sorry, that point is filled in because it includes, it has that equal sign, it includes 1, it does not include 1. So at f of 1, we're going to use the green line. We're going to use the blue line. At f of 1, we're going to use the blue line. Because it said is x is equal to 1, use the blue one. Where f is 0, I'm going to use the pink one. Because that's that point. Where f is 2, sorry. For f is 2, I'm going to use the green one. Which is the blue one. Because that's that point. Good? And they just want to know what the point is. You can either just find it on your graph, or you can put it into the equation, right? So when x is 0, we have f of x equals 2/3 x plus 1. When x is 0, what happens? F of x is 2/3 times 0 plus 1. That's just 0 plus 1. So f of x equals 1. So f of 0 equals 1. And for the other two, I need to use negative 2x plus 1 because they're down here on this graph. F of x equals negative 2x plus 1. F of 1 is negative 2 times 1 plus 1. Negative 2 plus 1, negative 1. So f of 1 is negative 1, which is true. And f of 2. Negative 2 times 2 plus 1, negative 4 plus 1, which is negative 3. So f of 2 is negative 3. Good. The domain and the range, remember domain is just your x. This is my domain. So on my x, I have an arrow going this way and I have an arrow going this way. I don't have anything excluded in here. There's one point excluded here, but it's included here. So my domain is all real numbers for my x. From negative infinity to infinity. Because I have arrows going both ways. I have every point covered, even though it jumps, it still covers negative 1. Good. But my range are my y values. So up and down. It goes forever down, right? It definitely goes to negative infinity because those are both going down. How high does it go? What is your highest point? Good. So you can think about, well, what is my highest point? It's on my first graph, right? And it's at x is 1. It doesn't include x is 1, but it's at x is 1. Good. So I can say f of 1 is 2/3 1 plus 1. So my highest point on my y is right here. So I put in that. I don't know what my x is. I need to find, or sorry, I don't know what my y is, but I know that my x is 1. I need to find my y, so I'm going to put my 1 in and see what comes out as y. So f of 1 is 2/3 plus 1. 2/3 plus 1, 1 is just 3/3, right? So 2/3 plus 3/3 is 5/3. So my range is from negative infinity to positive 5/3. Good. And then locate any intercepts. You can see after you graphed it that both of your intercepts are on the pink one. So remember what you do to find intercepts. Ooh, what you want to do to find intercepts is either make y 0 or make x 0. So when y is 0, 0 equals 2/3 x plus 1. Subtract that 1, so we get negative 1 equals 2/3 x, right? Now you're going to multiply by 3. 3 times negative 1 is a negative 3. And then divide by 2. So x is negative 3/2 when y is 0. And then when x is 0, what is y? Y is 1. Right? So we found that up here. Sorry, guys, I know I rushed through that piecewise, and we can do one more piecewise on Wednesday if you would like. All right. Thank you so much. You are free to go or stay if you need to.